Hello, everyone. As promised, today I'm going to go over implicit differentiation. So, welcome to your channel of Math Made Easy. Implicit differentiation is is the only way we do differentiation. Say what? Yeah, I will explain to you what I mean. When we say, for example, y equals 5x, okay? And I ask you to find dy dx, everybody would say 5 without thinking. But is it really 5? Yeah, it is. But how did we get it? If you think about it for a little while, I'm going to take the derivative of the left-hand side with respect to x. So I get dy dx or y prime. On the right-hand side, 5 is a constant. In fact, you can even go to the degree of saying it's 5 times it's a product, right? But it's not a product of two functions. It's a constant, which we know its derivative is zero. But just let's take it to the very basics. I'm going to say 5 times the change in x with respect to x plus x times the change of 5 with respect to x. Really, that is the thing. So we say, oh, how does X change when X change? That's a very dumb question, right? X changes exactly as it changes. So dx is 1. And that's why we don't write it. But you have to understand we are taking the derivative of x with respect to x. Also, if I ask you, how does 5 change if x goes from 1 to 2? And you say, this guy is crazy, right? Which you would be right. I'm crazy. But basically, what we are saying is that 5 is a constant. Constant meaning doesn't change. So why do you tell me how does 5 change? Right? You go back to elementary school probably and learn better math. But so I say, okay, I'm sorry to ask this question. It's 0. So the answer is 5. We call that when we take the derivative of y and the derivative of x, both with respect to x, we call that implicit differentiation. Why did I say that? Because I've seen it too many times to be comfortable. Is that I will give you a very simple example. Suppose we have a circle here, okay? This problem, by the way, doesn't require calculus at all. I have a circle, and let's say here is the center is the origin to make it easy, and the radius of that is something square, like 9 or 16 or even 25, so 5. And I ask you to find the slope at any point on that circle. So maybe I'll pick a point whose x and y when squared becomes, and I pick the 5 so we can say 3, 4, 5. Everybody knows that. So for example, I take a point here that is -4, +3, or -3, +4. I think we made it slightly to the left. So I'm going to say -4 and 3. And I ask you, find the slope of the tangent at this point. So the first thing you say, oh, I know the equation of that circle is x squared plus y squared equals 5 squared. So I can solve y equals 25 minus x squared, and then I take the plus or minus square root of 25 minus y squared, and then I take, oh, I say, wait, that's too much work. Why would you do that? Do the differentiation right away. And you say, how do I do that? Exactly like we did here, except that, of course, if it's a constant, we are going to ignore that. So I'm not going to say the derivative of 25 because I know 25 is a constant, it doesn't change. Okay, so I'm going to say the derivative of that, notice implicit differentiation and chain rule, both of them are used every time you take a differentiation. Here, I'm going to say it's x squared. What do I see first coming from outside? It's the square. So I take this, the square, I would make it a multiplier, decrease x by a power by 1, right? So it becomes 2x. And then I go inside the parentheses, that's the hypothetical parentheses here. And I take the derivative of x with respect to x. So I get dx, which is 1. That's why you say it's 2x. We don't try dx. And then we say, same thing here. I have y and a square. So I have two things, two functions, not one. There is a square function. So I take the 2, reduce the power of y by 1, and then I step inside the parentheses. That's the chain rule. And say, what is the derivative of y with respect to x? I say we call it y prime or dy dx. That's it. So I don't really need to find y explicitly as a function of x, but it can be implicit. That's a very simple example. I will give you more involved, two more examples to illustrate the point once and for all. And now I say the derivative of the right-hand side is 0. I divide both sides by 2, and then I move the x. So I'm going to subtract x from both sides. And then I'm going to divide by y both sides. So I get y prime or dy dx equals negative x over y. So at any point on the circle, I can find the slope by just substituting the x and the y. So in this case, it's negative. The x is negative 4. Oh, I'm sorry. Yeah, and the y is 3. So I get 4/3. Yes, the slope is positive and it's more than 1, right? I didn't need differentiation, let alone implicit differentiation to find that, because I knew that if I have the slope, the tangent here, okay, here is the tangent. If I draw a line perpendicular to the tangent, then we know from geometry that it passes through the center. So these two lines are 90 degrees. The slope of this radius, m, equals the change in y, which is 3. So I go from 0 to 3. That's an increment of 3. I go from 0 to negative 4 in the x, which is negative 4. So it's negative 3/4. Meaning that the slope of the tangent is the negative reciprocal. Negative times negative is positive. The reciprocal of 3/4 is 4/3. So I really didn't need, I'm just showing you, what we would have gotten if we had solved this problem with differentiation. Now let's take a more not complicated but more advanced thing. Because now even though it's implicit, but the x term was separate from the y term. But what if we combine them and we say, for example, sine y, and then I'm going to multiply it by something, or say plus x squared, for example. So let's take the first one and make it still separate to get used to it. And then the next example, I will give you something that is implicit. I think I picked it from somewhere online. Let's say this, we can add or subtract 4y, and we say the right-hand side is cosine x. So I have a combination of x and y. Okay? Let's do the implicit differentiation. The derivative of sine y, again, we have two things. We have the sine, which its derivative is cosine, and we assume everything else is x, so we don't change. So if that was sine of 5x cubed, I would say cosine 5x cubed, and then go inside the parentheses and see the function and take its derivative with respect to x. So the derivative of y with respect to x is y prime, or dy dx. That's what I see many students missing, especially in the beginning, because they try to memorize. No, you are taking the derivative of everything with respect to x. Plus, again, x squared. So it becomes 2x times the derivative of x with respect to x, which is 1. And that's why we don't write it. 4, negative 4 is a constant, so I don't care about it. The derivative of y is y prime with respect to x. When I go to the right-hand side, the derivative of cosine x is negative sine x. I go inside the parentheses, there is x. The derivative of x with respect to x is 1, so I stop. Next, you keep the y prime terms to the left and the constants or the non-y prime, it's not constant, but the non-y prime to the right. So the left-hand side becomes cosine y minus 4 times y prime, and the right-hand side would be negative 2x minus sine x. And finally, I get y prime by dividing. So I can take a negative outside, so these become positive if you prefer, or you can leave negative 2x minus sine x on the numerator, and you get cosine of y minus 4 in the denominator. I mean, you could, if you don't like the negative sign outside, you see that the denominator has a positive term and a negative term, so you can switch them and say this equals 2x sine x over 4 minus cosine y. Both are correct, of course, but that's how you do it. You would say, okay, so also each term here, I have two terms in y. I could have left them in to begin with and move the x squared there, and it would be, even though it's implicit, but it's easier because they were separated. Say what? That's exactly why I picked a problem. I didn't want to make that problem, and try to pick values. Anyway, this one is slightly different. It says you have an equation y squared e to the power of 2x. So now I have y and x together equals 3y plus x squared. And we want to find the equation of the tangent at point 0 and 3. First of all, let's make sure that 0 and 3 works. If y is 3, this is 9. If x is 0, e to the 0 is 1, so the left-hand side is 9. When I move to the right-hand side, 3 times 3 is 9, plus 0 is 9. So it's correct. Just forgot to check that. I know it has to be right, but we always check. Alrighty, so in this case, I see the first term is a product. So we use the product rule in differentiation, which is depends on how you learn it. You can say the first times the derivative of the second plus the second times the derivative of the first. And some people say the derivative of the first times the second plus the derivative of this. It really doesn't matter. It's a matter of like a commutative law, so to speak. So I'm going to take the first, which is y squared, and multiply it by the derivative of e to the 2x with respect to x. So when you have e to something, you take the first of all, it stays the same. E to the derivative of e to the 2x, you assume it's e to the x, so its derivative is the same thing. And then you go inside, so it's like e of 2x. It's the same. And then you go inside, you take the derivative of 2x, which is 2. So that's the first term. Plus the second, which is e to the 2x times the derivative of y squared, which is 2y. And then you go inside the parentheses. That's where many students miss, right? And take the derivative of y with respect to x like we did before, so it's y prime. This is extremely important, so don't mess it up. Then 3 is a constant. The derivative of y with respect to x is y prime plus x squared. The derivative of that is 2x times dx dx, which is 1. I keep saying that. So at every step of the way, you think, oh, at the end of the day, I have to multiply by the derivative of what variable I'm dealing with respect to x. If it's x, then you don't write it because dx dx is 1. If it's anything else, don't forget it. Many students forget one or both. If you forgot both, how can you solve for y prime? There is no y prime. Or if you forget this one, and this is very common, you will get a wrong answer because you would say 3y prime equals this plus this minus that, and then you divide by 3, and of course it's incorrect. So like what we did last time, I'm going to move this to the left and take, so just to save time, I'm going to say 2e to the 2x y minus 3 y prime. So 2 e to the 2xy y prime minus 3y prime equals 2x minus 2y squared e to the 2x. So y prime equals the right-hand side over this multiplier. Evaluated at 0 and 3, what do you get? 2 times 0 is 0, minus e to the 0 is 1, 3 squared is 9, times 2 is 18. At the denominator, e to the 0 is 1, times 2 is 2, times 3 is 6, minus 3. So I get negative 18 over 3, which is negative 6. Okay? That's how the slope is. So the slope is very steep going down. Then you say, okay, how do I find the equation? Remember, I told you when we did the equation of a straight line, don't memorize. Yeah, you say y minus y0 equals m. No, all what you have to do is to say, okay, here's a line. I have 2 points on it, and the slope is negative 6. If this point is 0 and 3, and this point is x and y. So I say the slope, which is the change in y over the change in x, x minus 0, equals negative 6. So no need to memorize anything. If you know that the slope is the change in y over the change in x, you could have written that as 3 minus y over negative x equals negative 6. So from here, you multiply both sides by x and you get y minus 3 equals negative 6x. And like many people prefer is to write it in slope intercept y-intercept form. So you add 3 to both sides and get the equation here of the slope of the tangent, I'm sorry, at point 0 and 3. I hope this was clear enough for you. And okay, I'm boring, but I have to remind you every time that you have any questions or you found something that I missed explaining or you want clarification, just let me know by dropping a line on my comment in my comment section. Otherwise, I wish you all the best and I hope to see you soon. Thank you very much.